Greetings and welcome back. So, we're in the midst of the final stretch here where I'm giving you several vignettes whose ambition is to reflect on what we've done the last 3 months. And so, I've talked about night science, I've talked about um, what we mean by mechanism. And here I want to just spend a little time reflecting again on the notion of what it means to understand a thing. And I've had a point of view this term, and I want to reiterate. My point of view is a subjective point of view. It's a subjective point of view that's shared by many people that are trained probably more in the physics side of things than in the biology side of things. But there are plenty of people on the biology side of things that share that point of view, and there are plenty of people in all points of view that won't share that point of view, and that's fine. I mean, that's what makes the world go round. So, one of the things that I've tried to emphasize this term is this idea of what sets the scale of X. And my point was and is that for me, subjectively, I want to be able to examine a phenomenon and I want to be able to say to myself, I understand what sets the scale. For example, today I was looking at the waves at Ocean Beach in San Francisco, and one of the things that anybody that observes the ocean, especially in the winter in California or Hawaii, will notice is that there are certain days at which you will see waves breaking a mile offshore. There's a place in France that I also know very well called Bellara, which is right near the Spanish border. And sometimes, you'll see waves breaking 2 miles out at sea. And so here's the question, what sets the scale? What sets the distance from the shore at which waves break? So people know the answers to these kinds of questions. It has to do with the depth of the water relative to the height of the waves. And, we've already talked about what sets the height of mountains, and that one was really fun. I showed you the Little Prince here because of the fact that you might remember when he was depressed. I think that I mentioned this earlier. The Little Prince watched the sunset 45 times in one day because his planet is so tiny. And he sat in a lawn chair, if I remember correctly, and he watched the sunset over and over again. It kind of inspired him. Why do I bring that up? Because in a world where the size of the system is so small, then the evolutionary force of genetic drift will be more important than it is in a large system, like in a giant cauldron of 10 to the 30th bacteriophages. So what sets the population size scale for evolution? So anyway, that was one of the things that I wanted to point out. I also wanted to revisit this issue of factual versus conceptual surprise, factual knowledge versus conceptual knowledge. And I think that juxtaposition is very important to bear in mind, both when listening to what other people have accomplished, and both of them are important, and in thinking about how you're going to consider your own work or your own learning. So, if I'm being a little bit snooty, I would say, that reviewer 3 might say to somebody that worked out the theory of the tides, your results on the monthly variation in the height of high tide are not surprising, since we already know that tides are higher at full moon. And I told you this earlier in the term. So did Babylonian sailors, and so does every 10-year-old California surfer kid, and that's not science. So, this issue of trying to be able to make a predictive model of the tides is totally different than the qualitative observation that there's a daily periodicity of the tides, but that daily periodicity has on top of it a piece that has to do with when the moon is full moon or new moon. And, that's deep and interesting, especially if you can calculate it. I already read this story, so I'm not going to reread it, but I just wanted to point out that, this issue of understanding, one of the axes upon which we can reason is the axis of abstraction. And so I like to think of researchers as map makers. Researchers are making a map of the world around them, and it doesn't help to make a map that's as big as the empire. That's not a useful map. I can't carry around in my back pocket a map of San Francisco that's the size of San Francisco. That does not help. And so, we need to tastefully try to exercise our judgment about which things we want to include in our map of natural phenomena in order to answer the question that we have in mind. Another one of my favorite little sort of vignettes about understanding has to do with the following thought experiment, which is, I haven't been on a plane in a year, more than a year, actually. And for me, that's the first time I can say that since I was 10 years old, maybe. So 50 years. That's the first time. And I've already called attention to the fact that I love the third dimension. It's probably, to my mind, one of the greatest achievements of human beings is to enter the third dimension. And I always like to imagine the following experiment. I'm showing here a Singapore Airlines flight. I like being on Singapore Airlines flights. And I want you to imagine this flight arriving in Los Angeles International Airport. And let's say this particular day that I had a nice pair of scissors with me, and I cut off all the seat belts. Now my question to you is, would the plane take off 4 hours later to fly back to Singapore? And I think all of you know the answer. The answer is no, it would not take off. And in fact, I have a friend who was on a flight, and the flight attendant's speaker didn't work, and they asked everyone to get off the plane. The plane didn't take off. So both of these cases, you could say, oh my gosh, that's the lethal speaker knockout or the lethal seatbelt knockout. It must be true that seatbelts are critical for flight. Of course, that's not true. So correlation and causation are intertwined in some weird ways that can confuse us. And to make matters worse, the physicists would come along and they'd measure the elasticity of the seatbelt and try to figure out what it might have to do, and it'd be completely misguided. So this is a story to exaggerate a point, but it's a point that's really worth making. And the point that's really worth making is that not everything we know is important to a given thing. You might be interested in flight, and if you're interested in flight, then the fact that there's a beautiful, high-tech, modern television in the seat has nothing to do with that, even though it's for sure a part of the plane, it's a part of the design, it's a part of the budget, it's part of the weight. All that stuff is true, but it's irrelevant to the nature of flight. We talked earlier, I want to show the picture of Sadi Carnot again. There's all these different Baroque steam engine designs that were present in the early 1800s, and I just think it's stunning that one can take this complicated diagram shown on the left and replace it with this very simple diagram shown on the right, which is the essence of what's going on in a heat engine. That's abstraction at its finest, the notion of the Carnot cycle. And then I think my last point has to do with the quote from the title of a paper by Eugene Wigner, The Unreasonable Effectiveness of Mathematics in the Natural Sciences. So, we wrote down the diffusion equation. We used it to look at the disposition of molecules that are jiggling around in solution. And I mentioned it, and I would like to have given a homework about it or covered it in a class, but it's really fascinating that this same exact equation describes the conformations of a polymer chain. And so, I think that was another one of the key points that I wanted to make this term, was just this idea of the unreasonable effectiveness of mathematics, and also the sameness. I had a vignette on sameness, but here I'm saying the sameness of topics which are ostensibly miles apart. The conformation of a polymer on the one hand, the jiggling of molecules like GFP in solution, or the movement of alleles in frequency space, all can be described by a diffusion equation. And for me, that kind of unity and sameness and that kind of effectiveness of mathematics is really stunning. So those are the things I wanted to say in this vignette.